So I need to clarify something. To find something that is not 100% true, I would first admit it, and I need to clarify this, that this is a differentiable function because the derivative exists for all points in the function's domain. So we know that 0 is not part of this function's domain, but all other real values are part of the domain. So this would be considered differentiable.
I'm sorry, what's today?
What is today? Today is Wednesday, September 7th, 2016.
It's just the 7th.
Okay, so let's clarify this. I know that Lena, you had asked a question about when it's differentiable, what's not differentiable, and I think the definition of it. So I need to clarify that this is definitely a differentiable function. Even though there is a vertical asymptote, we consider it a differentiable function because of the fact that the derivative exists for all points in the function's domain. And the function's domain would be all reals except 0.
No, is it important to understand, when it comes to this test, is it important to understand how to do the derivative with the function method, with the limit method, or can we use a shortcut throughout the entire test?
The test will tell you. You should be comfortable with both. Today we will be going into the shortcuts.
Oh, so by the test, not a test.
And if you remember this graph, what it looks like, the homework is also on the board there for those that were absent yesterday. We have, this guy would look like, so this is a differentiable function. Even though it's not a continuous function, it's considered differentiable because it is differentiable for every point except at 0, which is not part of the domain. So 0 is not part of the domain, but everywhere else, because it's smooth and continuous, it is differentiable. So this is a differentiable function.
I have a function that's why he's clarifying.
I will give you an example of a function that is continuous but is not differentiable on the next slide.
How do you know?
Because there's a
Oh, right.
So if we go back to,
What if it says like approaching 0? Would that matter?
We're not trying to,
Even if it was not approaching 0, it was literally on 0.
so this is the clarification that you may want to add on for those of you that were here yesterday to make it more clear. The derivative exists for it to be differentiable. The derivative exists for all points in its domain. Cindy, are you okay, man? Is everything okay? Can you please keep your head up during class at least and just soak it in? If you're not going to take notes, that's fine. Yes.
Just because I don't remember. When you're finding the derivative of a function, you do the limit of x to the point. Like if you're trying to find the derivative at a point, you do the derivative of the limit of x to the point, to the number, right?
So you say to the point, it looks just like when you have it in terms of, say, f of x. It's the exact same thing.
Yes. But
Instead of x plus h and x, it's a plus h and a.
yeah. But I'm asking about the limit of h to 0 there.
Okay, as we approach 0 from the right-hand side.
Yeah,
Yes.
I understand that. But I'm saying, like, if you're trying to find the derivative, like in the homework, if you're trying to find the derivative of this function at 1.
Can you show me
It's number 6.
what page is this?
105.
105. Number 6.
Yeah, so would you do f prime of x equals the limit of x to 1?
So you can find f prime of x and then
Yeah,
you're
but I'm asking
finding
what
you are finding f prime of 1 is what you are finding.
When you're just trying to find the derivative function,
Mm-hmm.
do you do the limit over x to 1? Is that it? Or what number do you put there? X arrow, what goes there?
X arrow. What do you mean?
Like
The limit, under the
zero.
The limit.
H?
Yeah, but it's x in this one.
Number 6?
Yeah.
And like the example, like the formula.
No, I think you're getting things confused here. H, remember H was the distance. Remember when we first discussed the derivative, we compared average rate of change and wanted to see what happened as those 2 points got closer and closer and closer. That H was the distance from those 2 points horizontally. That's all that was.
How long are you after tonight?
Yeah.
So if you look at right here, right there, you can see at the top. So just underneath section 3.1 exercises, you can see that.
Yeah, if you look down, that's for 1 through 4. If you look for like the 5 through 12 or whatever, it goes f of a equals the limit of x to a, so it's 1. So it is x to 1, right?
Which one was this?
Number 6.
Number 6. Yeah. So if you're finding the derivative of the function, you would apply the derivative formula. Same thing.
Okay.
So you're finding it at a equals 1. So then let's say you find f prime of x is, let's say it's 2x. Then if you want to find f prime of 1, 2 times 1 is 2.
Okay.
Think,
I
breathe.
remember we did this last year, but we used a shortcut, so I can do this via a shortcut.
Mhm.
But I'm just kind of confused about like where you're coming from. How long are you after today?
I'll be available probably for longer than you want to be here because I have the open house.
I have a club meeting until 3:30, and then I'm here for open house too, so I'll be here until 8:30.
I'll be here until open house, unfortunately.
Okay, so I can come by.
Fortunately, I'll be here till open house. Yeah. Okay.
So, but I can
So.
stop by after my meeting. It ends at 3:30.
Yeah, you can stop by. Yeah, so guys, I'm available if you want to see me after school today, please. My availability, come anytime after 2:15 today. You guys want to go over anything? So, this is differentiable. Let's try to not talk, let's try to focus on what's going on here. So I'm giving you an example of a function that is differentiable function even though it's not continuous.
Like I could do this in like 2 minutes.
I know, exactly.
The 2x plug it 2.
I know the shortcut. I know it too. I understand. But I'm telling you it's important.
What is 2?
I didn't know how to do the shortcut. I learned a long time ago.
I know, I just said English.
We're going to go into the shortcut today.
Yay!
Yay! But I could ask you 4 months from now to do something the long way, and I expect you to know how to do it.
Yes.
So that's the warning. We're going to reach a point where you can do the shortcut all you want. But if I throw in a test, show this using the limit, I will expect you to know how to do it. And I'm like, oh, Mr. Gross, I forgot to do it. I'm getting credit.
That's literally what we're gonna sound like. You really got it spot on.
So I'm letting you know that is expected to know, and it's important not just for your knowledge, but when you take the AP Calc exam, and there are limits on there, you have a deeper understanding. So it's not some foreign thing that you forgot about because you just do the shortcut for the past since after the first 3 weeks of Calc. You just now do the shortcut.
This is exactly why I'm coming
Okay,
after.
but we're getting there. Okay, let me continue with this. So, if we have, let's say, what is this, guys?
It's a line for out 11.
Absolute value, yes. So this is say something like
Why are they different?
f of x is equal to the absolute value of x. So here's a situation where this is continuous, right? I could take my finger and never have to lift it. It's continuous. This guy was not continuous, right? Because there's that vertical asymptote, it breaks at 0, but it was differentiable. This is an example, because I'm giving you both, where it is continuous, but not differentiable.
How is it not, oh, is it not differentiable because at 0, there's two different terms?
No, it's because it's not similar.
Because the definition which has been clarified for something to be differentiable is this. The derivative exists for all points in its domain. At 0 for the absolute value, 0 is part of the domain. 0, 0 is a point of this function. However, because it's a cusp, or sharp turn as we discussed in the last class, it's not differentiable. So an example of a function that is continuous but not differentiable, in the previous slide, a function that is discontinuous but considered a differentiable function.
Why is it
Not differentiable, but this is like the sharp, like this is, you know what I'm trying to say. About a 0.
That's not the right hand.
What's that?
It's not differentiable because at the bottom, it's like sharp turn.
Yes, because it's a sharp turn. There is a point that exists. 0 is part of the domain, but because it's a sharp turn, it's not differentiable.
So it's like smooth on the other slide.
Correct. It's not smooth. Very good.
And then,
It's not
Can you
smooth.
go back to the differentiable definition? Or the
Not smooth at x equals 0. So if we go back to the differentiable definition for differentiability, something is differentiable, it's smooth and continuous, and the derivative exists for all points in its domain.
So why would the derivative exist for 0?
For the absolute value?
Yes.
Okay, good question. And this was discussed in the last.
Wait.
So this was discussed in the last class. Keep in mind now, thankfully, all the videos and flip cards are now available. So anytime you miss a class, you can always review the last lesson. Henley, is your mom okay? Your mom's cheap?
she's good.
Okay, can you please get off your phone and join us? Okay, can you please join us? Okay, you're obviously on your phone texting or whatever. I mean, that's kind of rude. We're in the middle of class. Did I do something to offend you? Okay. Are you understanding this? What's going on?
Because A is 1, and there is 1, there is a number for the derivative, so the derivative is 0.
So the mathematical reason of why this is not differentiable at this point.
F of 1 is 5.
The limit, if we take a one-sided derivative one-sided, it would probably be, -1, the derivative. In fact, it's -1 the whole way. +1 the whole way from the right-hand side, which is discussed in the previous lesson. The fact that they are not going to match, right-hand side limit as x approaches 0 from the right-hand side, and from the left-hand side, they don't match, aka where we have a sharp turn or cusp, it's not differentiable.
So all curves are considered differentiable.
Yeah, if it is smooth, it's going to be differentiable for those points.
Well, it's
Yep.
Yeah, okay, and then the 1 over x, I get the non-continuous, but how is that differentiable? I think you said it, how is it not differentiable?
Because it's not continuous, how is it differentiable?
Why is this differentiable?
Yeah.
Okay, it is not differentiable at 0, but the function is considered a differentiable function because of what I have written right here.
And because 0 is not part of the domain.
Yeah, so
because
it's
it's
okay.
x plus
Gotcha.
2.
No, we could then you would get 4x.
It's also a curve.
Because it has to be 2 and x minus.
No, then you get 3x.
Plus 4
You can,
minus.
what if you just multiply that by 2 and then you get and then maybe then you could
Like expand that.
like if you just multiply the 5, it should be 5x squared. Yeah, and then you 5x squared over and then
Theorem 1 is pretty straightforward. It's good to just to know it as a fact on page 113. Differentiability implies continuity. Now we're talking, but yes, a specific point, of course, because the 1 over x. But then again, that still wouldn't affect this at all because it would not be differentiable at 0 for the 1 over x reciprocal function. But it just, theorem 1, if f has a derivative of x equals a, then f is continuous at x equals a. Very simple.
So, now, would they ever ask for like the exception with the 1 over x graph?
What's that?
But it's not to say it's continuous, when, and he said, in the book it said that differentiability implies continuity.
Yeah, because that function is not differentiable at 0. Okay, let's move on to section 3.3.
I have a question.
What's that?
On the homework, it's telling us to use a whole different function that we haven't looked at, and why is it telling us that? Like, it's telling us to use f prime of a equals the lim of x to a. F of x,
What page is this? 105?
Yeah.
What
F
number?
of x minus 6.
Number 6.
Like, why is it asking us to use that definition instead of the one we've been working with?
Use the definition to find. Oh, that's just the alternate version. You can do that too. It's the same thing.
So should we use the other one?
You can use whichever one you want. You can use whatever you want. The way this works out, if you notice, especially looking at the bottom, as x approaches a, the bottom would be going to 0. Just like if it were h in the bottom, as h was going to 0, it's the same principle. It's just a different way of writing it.
Okay, I like the other one.
You can write whichever way you want to, whichever way you want to do.
Okay.
It's not a bad idea to be familiar with both, but they're the same exact idea, no matter which one you use. Good question.
Like, it's not.
Yeah, I thought the expert before was. That's one that I'm
So some basics for some rules here.
Joke's on you.
And then that's x minus 1 it's x squared. Yeah, but it's just factor it. And then the x minus 1 is that it?
Don't worry too much about the homework in the sense that I'm going to give you full credit if you at least do attempt the problems, and we will be going over the homework on the day that it's due. Don't worry too much about it. Rule 1, just the derivative of a constant is 0.
Wait.
You should feel very comfortable with this, so let's make sure that we are comfortable with this. The derivative of a constant with respect to, say, change in x is 0. It just, another way of saying the derivative of a constant is 0. Remember, there's different ways to say things.
The derivative of 2 is 0.
Correct.
Cool.
I like this one.
Power rule, so I'll just give some examples to go with these.
I like that.
So if you had d dx of 2, this would be 0.
You can just like at the end say what it.
Power rule, the shortcut. Alright, so the derivative of, say, something x to the n, or if n is a positive integer, then you would result in n x to the n minus 1. Example there.
There's the shortcut.
We have the derivative of, say, x cubed. This would equal to 3x squared. Constant multiple rule, sum and difference rule, If u is a differentiable function of x and c is a constant, then this holds true. This is basically just like rule 2. It's nothing different. There just happens to be a c in the front of the differentiable function. You guys would know it if you saw something like example, if you took the derivative of, say, 3x squared. You know, the way they're talking about it is that you can hold a 3, but it's the same idea of 2 to the front, 2 times 3 is 6, and then dropping this down a power. So let me actually go and actually show that. So the 2 is going to be with the 3, and then dropping this down 2 minus 1.
Don't you love this board?
I do, actually. I do. Overall, it's been pretty good. Let's not jinx it. 6x.
And this is a different it's going to be plus 2 times like so
Sum and difference is just, there's nothing weird about it on rule 4.
You're kidding me?
Why would they do that?
Over.
They would have the odd answer or something.
That's like every math. Yeah, that's like every math.
I thought it was only even.
And it was great because it's trying to use the only assignment.
All right, let's go into one that is product rule.
Can I see what I got? Because I got,
We're not gonna do.
So if you have something like, take the derivative.
Are we skipping rule 4?
4 was, yeah, it's pretty straightforward.
Oh, right. Okay.
It's basically, it's the idea of,
It's written in math.
it's the same idea as if you distribution. That's all that really is. So I want to focus on this.
Yeah, use the
so you
It's,
do.
it would be
Or plus O. It's just 2x. It's just 2x. That's it. It's 2x. And then if x, what's x? X is 1, so it's 2.
It's okay.
Wait, what is it on there?
We have x on the square root of x plus 1 plus 2x minus 3 on the square root of x plus 1. Minus
So all this is saying here is, let's say you have u and v can be viewed as 2 different differentiable functions, and you want to take the derivative of them if they're a product. Derivative of the first guy, leave the second guy alone, plus leave the first guy alone, derivative of the second.
Did you put those together somehow?
times the second
Or
minus 3 times
We briefly went over it.
it's no, it's x minus know that you're
I like how we give history lessons too.
Mm-hmm.
Hey, can you give us an example of that one? Like a numbers example, not math.
Not math speak.
So like with numbers, not.
Yeah, this is written in math speak. I don't speak math.
You're going to have to recognize that a common derivative, say, of a trig, let's say, of derivative of sine of x, for example, is cosine x. So let's say we take the derivative of, say, x squared times the sine of x.
We just do it in numbers. Not trig functions. Yeah, like 1, 2, 3, not trig functions. Can we do it, please?
Just like
Why
I
is this one?
I'm allowed to finish it?
No.
Okay, so the derivative of the first one is going to be 2x. Leave this guy alone. Plus, leave this guy alone times the derivative of this guy, which is cosine x.
Yeah, we did this.
I know it's new to you, but it's not a huge shocker. I'm just letting you know that here sine of x is cosine x. Just accept that as a fact.
Accept it!
No, I remember that.
We did this.
So there's an example.
Yeah.
What would another example be with only numbers?
I'm still writing this one down.
I don't need letters and.
Only numbers. Well, it's going to be 0.
Why would it be 0?
Okay, only numbers, derivative of constant is 0.
Variables too.
A lot of new variables, okay.
Yeah.
There's no trig, no trig.
Yeah, you
No one
have
likes
to
trig.
use variables.
Okay.
I like trig. I just need to see the basics first.
Yes.
This is a very basic one.
I think basics.
Yes, I will. Yes, I will do it. Here we go. Example where we have knock this down one. Example is say the derivative. If the door just be closed, I'm in trouble.
I'll do it.
Once.
Okay. I'll say that to my boss when I get in trouble.
I will.
All right, so the derivative of.
These shells values honest opinions.
May you go to this one? Yes, you may. Half is available.
The darns.
So you're going to see, just say, let's say, derivative of x squared. We're trying to get something that I could write to where I would not want to just simplify this guy first.
Z to the third. That's good.
Well, if I take the derivative with respect to change in x, I believe I'd be the derivative of the first guy, which is 2x, leave this guy alone, plus leave this guy alone, the derivative of this variable, the change in this variable with respect to change in x, I said on own, I believe would be 0.
But it would be 3z squared.
Wouldn't it?
If I'm taking the derivative with respect to change in x. So let's not do this, I don't want to confuse you guys.
Oh,
Let's
true,
not
because you're
make-
only
let's not
changing
make it
one of the
confusing.
values. I couldn't see the end of the week.
Don't worry about it. Let's do,
I never knew this body was not making sense either.
let's do x to the 5th. If you want to view this guy and this guy as two different guys.
How did you get one?
So what happens when you have two different variables like that?
Why don't you need to?
Well, you only change, you wouldn't change the z one, because you're only changing it in respect to x. So you wouldn't take the derivative of the x, of the z one, right?
Yeah, so his change would be nothing.
Yeah,
I think we would treat it like a
Z would be
constant.
almost, yeah, it'd be like constant.
Yeah. But, so
Take
anyway,
the derivative of 2x.
let's not worry about that yet. I did not throw that in there to confuse you, but anyway, so let's do something that's basic. So,
2x, x to the
so we have the derivative of the first guy, leave this guy alone, plus leave the first guy alone, the derivative of the second guy, which would be 5x to the 4th.
And then you gotta simplify it though, because you just multiply the x.
Of course, I mean, it would have been so much easier to just do, you know, simplify this, but.
Yeah, but it's not right anyway. So.
All right, so quotient rule.
No, that's 21. I do remember this.
No, I'm saying if you simplify, she must have done x squared times x to the fifth, you get x to the 7, which derivative would be 7x to the 6.
Yeah, and you can get that.
One of the most feared rules.
Dun dun dun!
Can't wait to rewatch this, just kind of the random sounds that come out of it.
Do they hear us too?
Yeah, they hear us.
That has to be so weird.
So, the way that I wrote the product rule, the way that I wrote the product rule was such a way because I wanted to make sense for the quotient rule. You can do any homework anywhere you want to do homework, but we're kind of in the middle of the lesson. So the way I did this was, there's a reason why I did it, because specifically derivative of the first, and then leave the first alone, the second part, because it helps with memorizing the quotient rule. where order does matter because there's going to be a difference here. So derivative of the top guy, the numerator. So du dx, leave this guy alone, minus, leave the numerator alone, the derivative of the bottom, all over the bottom squared. This is the quotient rule.
So it's the, oh,
Yeah, I did that too. I used to believe that this, I just don't remember the context.
Yeah, we need it. It's kind of, I just maybe never really kind of spelled it out.
but we did do this.
So an example. Derivative of the top would be 6x. Leave the bottom alone. Minus, leave the top alone. Derivative of the bottom. All over the bottom square.
That's probably what we did.
So it just seems like so much less complicated.
Wait, is that what you?
See, but then it would, I don't know if you'd be able to switch it back.
If you raise it to the sine negative 1
Yeah.
of x,
So you have 3x squared.
and you take the derivative, that would be cosine negative 1 of x. You move that back down, and then it'd just be 6x times the sine of x. Like, this seems so much more complicated.
Yeah, I know what you're saying. I get what you're saying. It's not the same thing. I feel like this should be like.
Wouldn't it be negative?
If this is.
Is there a question?
No.
Yeah.
Yes.
So if we were, when I learned how to do this, what I would have done is I would have moved sine up to the top with sine negative 1 x, just taken the derivative of everything, and so that I would have gotten 6x times cosine negative 1 over x, moved cosine back down, and it's just 6x over cosine of x.
So if your question is, can you write a quotient as a product, the answer is yes.
No, because remember, instead of just taking the derivative of both, with the product rule, you have to do like the derivative of 3x squared x cubed, and then leave sine the negative 1x by itself, and then do leave that one. You have to
No.
when you move this up to the top, you have to use the product rule. So do where you like take the derivative of one, leave the other one, and then take the derivative of, or leave the first one, and then take the derivative. I think it is.
So the thing is this, if you have something that's properly written like this, where you would not leave this written as, say, 3x squared times sine of x to the negative 1 power, and you try to just say, okay, I'm going to avoid the quotient rule, I'm going to do the product rule. Okay, go ahead, you can do that, but you're going to find out, you're going to do all this work, and you're going to end up, it would actually would have been shorter to do the quotient rule, believe it or not.
Okay.
Is that what we do with that? See,
I mean, you go ahead, you can try to simplify this a little bit, but the big picture is definitely just being careful when doing these. Derivative of the first guy. This is not going to really simplify that much at all, I don't think.
So it's 3x squared.
These don't have a common factor besides 3x, and that's not going to really do much for you there. Question? Yes.
no question.
I hope you have a question. Multiplying the numerator? Where's that? Are you sure?
Maybe. I'm pretty sure I
Does
got
that
it.
have the diagram going?
Well, tell me what you're confused about, I can probably help you.
I was confused because like,
You got it?
Oh, because we know what the.
Sin of x goes for 0, so that's cosine. Yeah, that's cosine. It doesn't matter because you're plugging it in.
That seems so easy for this. What?
It's okay. Oh, we have a whole lot. We had 2 days to do it.
Does anybody know what the derivative of cosine is?
Derivative would be sine.
No, it's not. Cosine is the derivative of sine.
What's the derivative of cosine? Are we, yeah.
What is the normal one?
Yeah, you do have to know that.
We
The
learned
derivative of
this.
what, cosine of x?
Yeah.
Negative sine of x.
There you go. Yeah, we didn't learn that.
Are we not learning it?
We'll probably learn it.
A sign, isn't sign referred to?
Sine goes to 0.
They cosine, well, this is, yeah, this is cosine, this is a cosine,
We need negative.
and then this is a sine.
I think it's
And
C.
that's,
Because it's again.
Yes.
Oh wait, C is not sine. It doesn't continue. It just look. It just goes like.
Right.
That is not
take,
sine.
what's the graph, this is more like, that is not, it's okay.
That's what is it? That's a cube.
This is going to be due on Friday.
Girl, we can like have so little homework in this class. I know, but it's just this week is
Are you going to college now? Okay, what is
Yeah.
Is that the Athletics college name? And it's on
When is that?
Thursday?
This Thursday.
I have a list of the colleges that are gonna be this too.
So what's the question?
No, I haven't been doing the homework down.
No.
Like, I think it's I think that with all this money, I got like or something, but.
Running more information we're going to gain by going.
Yeah, and it's like, the reason why is money.
I don't want your money. I want your money.
No, that's true.
I don't think I'm going to get anything out of it.
Yeah, okay.
Do you have to worry about money?
I don't know what functions.
You don't know exactly what's going on.